Scientists found something terrifying inside a black hole. You will have often heard about black holes. Those places in space where gravity is so strong not even light can escape. It's hard to believe that there's anything more terrifying than that. But scientists recently discovered something hiding inside one of these holes that has left them baffled. Black holes are scary enough on their own. Their gravity literally sucks in anything that ventures too close, stretching it and distorting it until it disappears over the event horizon and is lost forever. But the thing scientists found inside this black hole suggests that the universe might be even more dangerous than we thought. So what did they find? Let's take a closer look. A few years ago, astronomers working with NASA's Chandra X-ray Observatory were observing a black hole that was located 28,000 light-years away. This black hole is known as V4046 Sagittarius, and it's around 70 times heavier than our Sun. It had been relatively inactive for a while, but suddenly it started sucking in matter at a furious rate and heating up to millions of degrees. The material that it was consuming created two bright spots of light on either side of the black hole, which remained there for months before disappearing. This caught the attention of scientists who realized they might have witnessed something truly special. They continued to observe the black hole and noticed something strange. Every time it consumed a small amount of material, it would spit most of it back out again. However, some of the material would disappear without a trace. This puzzled scientists because they could not understand why the black hole would spit some of the material out again. Normally, once something enters a black hole, it cannot escape. So why was this black hole actually expelling some of its consumed material? In order to get to the bottom of this, scientists began searching through data collected from other black holes in an attempt to find a pattern of behavior. They looked at nearly 300 black holes that were relatively close to us, but they all appeared to be different from V4046 Sagittarius. Just when they were about to give up hope, they discovered another black hole that displayed similar behavior. It was located 10,000 light-years away and was twice as massive as our Sun, known as M2336. This black hole was also expelling material after consuming it, just like V4046 Sagittarius. At first, scientists were excited by their discovery, believing that they had finally found the answer to this strange phenomenon. However, as they continued to study it, they soon realized that there were some key differences between the two black holes. To better understand what was going on, scientists used computer simulations to model the behavior of these black holes. They discovered that, in order for a black hole to expel material after consuming it, it needs to rotate at a very high speed. If it rotates too slowly, then the material will simply remain inside the black hole. But if it rotates at just the right speed, then it will be able to expel some of the material and keep some of it inside. But there was still one major difference between the simulated black hole and the real-life one. In the simulation, the expelled material formed a disc shape around the black hole, whereas in reality, it appeared to be coming out of a thin stream. Scientists worked tirelessly to figure out how this stream was being created, and eventually they discovered that it had everything to do with the shape of the black hole's event horizon. Normally, the event horizon of a black hole is smooth and featureless. But if a black hole rotates at the correct speed, then it creates an interesting effect. The rotation causes the event horizon to warp and twist, creating small ripples that extend outward from the black hole. These ripples cause the space around the black hole to become unstable, which causes the material that's being consumed to bunch up and form a thin stream. But here's where things get really interesting. The stream doesn't just form around the black hole. It actually extends outward into space and can reach millions of kilometers in length. This means that the material that's being consumed isn't immediately pulled into the black hole. Instead, it gets stretched and twisted along this stream until it's eventually torn apart and pulled in. This process can take weeks or even months, which explains why the material that's being consumed doesn't immediately disappear. So what does this mean for the future of black hole research? Well, it means that scientists may have just discovered a new way to study the inner workings of a black hole. By observing the stream of material being consumed by a rotating black hole, scientists may be able to learn more about the physics of these mysterious objects. Additionally, this discovery could help scientists better understand the behavior of matter under extreme conditions. By studying how material is stretched and twisted as it's pulled into a black hole, they may be able to better understand the fundamental nature of gravity and the fabric of space-time itself. But perhaps most importantly, this discovery could help scientists better predict the behavior of black holes in the future. By understanding the conditions that cause a black hole to spin and the effects of that spin on its surroundings, scientists may be able to better predict how black holes will evolve over time. This could help them better understand the risks posed by black holes and develop strategies for mitigating those risks. Overall, the discovery of the new type of black hole is an exciting development for the field of astronomy. It suggests that there's still much more to learn about the universe and its mysterious phenomena. With continued research and exploration, scientists may be able to unlock even more secrets of the cosmos and better understand our place in it. When the researchers saw the data, they were stunned. It was exactly what they had predicted theoretically. The actual properties of the fast-spinning black hole were consistent with the model. The mass of the black hole was around 19 times larger than the mass of our Sun. Its spin rate was almost at the theoretical limit. The size of its accretion disk was also in good agreement with the prediction. But this was just the beginning. Over the next 2 years, the team made several remarkable discoveries. First, they found that the bursts of radiation were generated by clumps of material falling onto the hot surface of the accretion disk. Then they found that the material on the disk was structured in spiral-shaped arms, probably due to the swinging motion of the clumps. And finally, they discovered that the material on the inner edge of the disk had a peculiar motion. It was moving in an unexpected retrograde motion, opposite to the direction of the disk. This suggested that the material was somehow being pushed back from the center of the black hole. This was totally unexpected. According to Einstein's general relativity, anything that crosses the event horizon of a black hole cannot come back. So how could the material on the disk be pushed back? To solve this mystery, the team developed a new three-dimensional general relativistic magnetohydrodynamic simulation code. With this code, they were able to simulate the complex interplay of gravity, electromagnetism, and fluid motion around the black hole, and what they found was truly astonishing. The material on the disk was not only being pushed back, it was also forming a large-scale magnetic field that extended millions of kilometers into space. This magnetic field was so powerful that it was able to counterbalance the gravitational pull of the black hole and push some of the material back away from the event horizon. In other words, the material was actually escaping from the black hole. But wait, there's more. The team found that the strength of the magnetic field depended on the spin rate of the black hole. The faster the black hole spun, the stronger the magnetic field became. And when the black hole spun at near the theoretical limit, the magnetic field became strong enough to push material all the way back to the surface of the star. This meant that the material was effectively recycled back into the star, which could power a long-lived high-energy state. These findings have shocked the scientific community, and for good reason. They challenge our understanding of black holes and stars. We know that black holes can influence the properties and evolution of stars in a number of ways. For example, black holes can trigger star formation when their gravity disturbs a cloud of gas and dust. They can also destroy stars when their gravity pulls them apart, or when the stars orbit too close to the black holes and are torn apart by tidal forces. But this is the first time that we've seen a black hole power a star. This discovery has also raised a lot of questions. For example, how common is this phenomenon? Are there many stars out there that are powered by black holes in this way? How do black holes and stars interact in such a complex way? And can we use this knowledge to better understand the evolution of galaxies? These are just some of the questions that scientists are now working to answer. This is an ongoing investigation and scientists are eager to learn more. One way that they plan to do this is by observing other black holes in the night sky. There are several known black holes that are in a similar mass range as the ones studied in this research. By observing these black holes, scientists hope to see if the same phenomenon occurs. They are also developing new theoretical models to better understand the interaction between black holes and stars. These models will help scientists interpret the data that they collect, and will also help them make predictions about what they expect to see in the future. Overall, this discovery has opened up a whole new area of research in astronomy. Scientists are excited to explore this phenomenon further and to learn more about the amazing universe that we live in.